In this lesson, we're going to take a look at the idea of solutions. What is a solution? First of all, a solution is a number that makes my equation true. And you may say, you mean like the answer? Yeah, it is the answer. It's technically called a solution. So here's my question. I have this equation, x plus 7 equals 10. My question is x equal 4 a solution? And you'd be like, I don't think so. How would you prove that it's not a solution? It seems like a little bit of extra writing now when you could just do it in your head, but we're going to go through it. So I'm asking, I think x equal 4 is a solution for this. How do we prove it? Substitute in x equals 4. Okay, so I rewrite 4 plus 7. And the question is it equal to 10? Order of operations, 4 plus 7, 11, equal to 10? No. So if it's a solution, it's the number that makes my equation true. True means equal on both sides. 4 is not a solution. Okay, so it's not 4. So is it 3? 3 plus 7 equals 10. Order of operations, 10 equals 10. Yes, that is a solution. As a matter of fact, this is the only solution that works. There are no other numbers I can put in here for x to add 7 and get exactly 10. So in this case, I only have one solution. So let's build off this idea and look at a different type of equation. What makes this equation different? Well, if you first look at it, you'd say, wait a minute, there's two variables in it. Right, there's an x and there's a y. I still can answer this question of, is this a solution to this? For instance, three, 5. Now you may be thinking, wait a minute, that's an ordered pair. Why did you just write an ordered pair? I want you to think about when you graph ordered pairs, what are you actually graphing? What do the numbers actually stand for? The 3 stands for which axis? That's my x-axis. The 5 stands for which axis? That's my y-axis. That's why I wrote an ordered pair, because I need an x number and a y number. So my question to you is 3, 5 a viable solution for this? Let's try it out. I'm going to substitute variables. X is 3, so this is 2 times x plus 3, so now that's 2 times 3 plus 3. On the other side, y equals 5, so instead of writing y, I put 5. You can probably look now and say, wait a minute, that's not going to work. Let's try it out. Order of operations. This is 6 plus 3 equals 5. 5 equals 9. That's not a solution. So the question is, can I get something that's a solution? So let's try this. Is 2, 7 a solution? I still have an x number, I still have a y number. So let's substitute in x. Instead of 2 times x plus 3, I'm going to put 2 times 2 plus 3. On the other side, I'm going to put 7. This is 7. This is 4 plus 3. 7 equals 7. So yeah, this is a solution, a pair of numbers that makes this true. Now, the other thing is, it's an ordered pair, so these have to work in unison. They have to work together. So when the x is 2, the y must be 7. If I would try 2 with anything else, it's not going to work. The only number that, when you put 2 in, works is the number 7. So this is a solution. How do you prove it's a solution? Substitute in variables, order of operations, and get to a point at the end where they're equal in value, because that's what a solution does. Okay, one more trip through. This is my equation. I have two variables. But in this case, instead of someone saying, here's an ordered pair, is it a solution? What if you're not given any solutions and it's our job to figure them out? I need an X number and I need a specific Y number so that when I put both of them in, I get equal value on both sides. Now remember, I'm going to need an ordered pair because I need an X value and a Y value. What else in math has an X and a Y paired together? Ordered pairs. The easiest way to do this is to think about making a table, and then these will become ordered pairs. So let's think. I need numbers. Now I could sit here and guess and check. I could think, okay, if I put a number in X, what's the number in Y? Well, that's kind of what we're going to do, but we're going to do a little more uniform so we actually have a process. It's easier to start with the X value. Now here's why. The X is the one that actually gets calculated, because then it just tells me what the Y is. If I try to start with the Y first, I'm going to have to think backwards. So let's start with the X. You get to pick a number. Now think about it. What's the easiest number to pick to calculate with? Let's go with 0. 0 for X. So I'm going to erase the X and say, do order of operations. 3 times 0 minus 2. Oh, that's 0 minus 2. So that means that Y is equal to negative 2. So in my table, when I put 0 in for X, I get negative 2 as the response. You just found a solution. This counts as a solution, because this X and this Y, when I put them in, makes the equation true. I get negative 2 on one side, I get negative 2 on the other. They're equal. Now when we did this the first time around, we only ever got one solution. The question is, can I find other solutions? I picked 0 for X. What if I picked 1? 3 times 1 minus 2. 3 minus 2 equals 1. 1 equals 1. There's another solution. Can I keep doing this, I wonder? What if I picked a different number? 2. 3 times 2 minus 2. 6 minus 2 equals 4. 4 equals 4. There's another solution. What if I kept doing this? What if I picked 100? 3 times 100 minus 2. 300 minus 2. 298. Can this process keep going? What if I pick negative 1? 3 times negative 1 minus 2. Negative 3 minus 2. Negative 5 equals negative 5. This process will never end. You can create an infinite amount of solutions simply by picking a different number for the X, a different number for the X, and then put it in and calculate it. This will go on forever. Wait a minute, what if someone says, show me all the solutions to this? You'll never be able to show all the ordered pairs that make this equation true. I want you to think back real quick, flashback. X greater than 3. Name all the numbers bigger than 3. Ready, go. 4, 5, 6, 7. When are you going to finish that list? You never will. How do we show somebody all the numbers bigger than 3? We would make a picture. We would graph 3, open circle, shade everything to the right of it. That's how we would do it. Guess what? We're going to do the same thing here. But notice what kind of picture you have. These are ordered pairs. What do I do with ordered pairs? I graph them. 0, negative 2. 1, 1. 2, 4. 100, 298, I don't have room on my graph. -1, -5. Now, I know this is a small picture, but I want you to look at the dots. Do you notice anything with your ordered pairs? How do I show all of the dots? Ordered pair, ordered pair, ordered pair, ordered pair in between, ordered pair in between. My picture's off a little bit. What I want you to notice is all of these solutions, an infinite amount, will make a picture. The dots are off. It will make a straight line. And this is how you show all of the solutions, the millions and millions of ordered pairs that make this equation true. And when you start graphing your solutions, which are ordered pairs, you will get a straight line.